Okay, in this lesson, we're going to be looking at Unit 8, Chapter 11, Permutations, Combinations, and the Binomial Theorem. We're looking at combinations, and we're looking at permutations versus combinations. So as I said, Section 11.2 in your text, and the focus is going to be on explaining the difference between a permutation and a combination. That is the main focus of this lesson. And also determine the number of ways of selecting R elements from n different objects. Okay, you should have already learned at this point what a permutation is, and we're going to compare permutations and combinations now. A permutation, the important thing with a permutation is that order is important. A permutation is an ordered arrangement of or sequence of all or part of a set. For example, the possible permutations of the letter A, B, C, and D are ABC, ACB, BAC, BCA, CAB, and CBA. Notice that order is important. It's the number of ways of arranging these three letters. All of these arrangements are different. For example, here's an example of a permutation. 10 people participate in a race. How many possible ways can the position of first, second, and third be determined? And if you think about it, in terms of trying to determine the answer here, how many choices can we possibly have for the first place position? And you should agree that there are 10 possible choices for the first place position. For the second place position, there are now 9 possible choices, and for the third place position, there are now 8 possible choices. So the answer is simply the product of these three numbers, which is 10 times 9 times 8, and I just have to do that, and we get an answer of 720. Another way to do the same question is to think about it as a permutation of 10 choose 3, because order is important in those three that you're choosing. A permutation of 10 choose 3, you should remember your formula for permutation. It's 10 factorial over 10 subtract 3 factorial. And if you do that, you get 10 factorial over 7 factorial, and if you do it on your calculator, you will still get the answer of 720. So there's two ways to think about that question. But it's a permutation because order is important. There are 3 positions. It does matter the order in which someone finishes the race. A combination, on the other hand, which is what's new to this lesson, order is not important. Is a set of objects without regard to order. A selection of objects without regard to order. All the 3-letter combinations of P, Q, and R and S, so there are 3 letters here, are 3-letter arrangements of PQR, PQS, PRS, and QRS. That's it. Arrangements such as PQR and RPQ, so in other words, if I were to rearrange these 3 letters, they're really the same combination. So the question is, of course, how many 3-letter combinations exist of PQR and S? PQR is the same as PRQ or RQP. It's the same 3 letters. Order isn't important with a combination. You're selecting 3 letters or 3 numbers or 3 objects, but order is not important. Example, you're choosing 6 numbers out of 49 for Lotto 649. The order in which you choose them does not matter. They are the same 6 numbers. Doesn't matter the order in which you choose them. You still have the same 6 numbers in the end. So order is important. Choosing 6 numbers out of 49 in this case is actually a combination, not a permutation. And we're not quite ready to do that example yet. So I just put it in there as an example of what a combination would look like compared to a permutation. We need to learn our formula for a combination shortly. Okay, let's identify first of all whether or not something is a permutation or a combination. Let's look at some examples here. My fruit salad is a combination of apples, grapes, and strawberries. Is order important? That's the question you need to ask yourself. Is order important? Does it matter the order in which I place these things in my fruit salad? And the answer is no. So if order is not important, then it's a combination in this case. Order is not important. That's the key. A combination to a safe is 3 numbers. Now note the word combination here. The word combination does not necessarily mean it's a combination. The combination to a safe is 3 numbers. What are the possible combinations? Is order important? When you try to open a safe, is the order of the numbers that you choose important? And the answer is yes. This is actually a permutation, not a combination. So a combination lock, for example, order is important in opening a combination lock. It should actually be called a permutation lock because it's a permutation. For example, if you tried the numbers 15, 23, and 7, that is completely different than trying 7, 15, 23. That's a different combination. Order is important when trying to open up a safe or a combination lock. So order is important. So because order is important, it's a permutation. Next example, in a CD of the month club, you can choose 5 free CDs from a list of 50. Is order important? The order in which you choose those 5 CDs doesn't matter at the end. And the answer is no. Order is not important. Once you choose your 5 CDs, you've got the same 5 CDs regardless of the order in which you chose them. Doesn't matter the order in which you choose them. In the end, you still got the same 5 Ds from that CD of the month club. So order is not important, so this again is a combination. 5 people run a race, and how many ways can first, second, or third place be awarded? And again, we just saw me do that example. That is a permutation. Because order is important. The order in which they finish is important. That's a permutation. So have a look at a couple more examples here. Now we're going to actually solve these. Which problem is a permutation and which is a combination? Solve each. A. From a group of 4 students, 3 are to be elected to an executive committee with a specific position. The positions are as follows. The first position, someone will be selected as president. Then someone will be selected as vice president. And then the third position, someone will be selected as a treasurer. How many ways can these 3 people be selected from the group of 4 students? Well, is order important? First question you need to ask yourself. And the answer is yes, order is important. Because if you choose someone for president, you can't choose them for vice president. So order is important. And if order is important, it's a permutation. And again, you would have learned in the previous section here now that if it's a permutation, it's a P of 4 choose 3. You've got 4 people. You're choosing 3 of those 4 people where order is important. It's going to simply be 4 factorial over 4 subtract 3 factorial. And that's simply going to give me 4 factorial over 1 factorial, which is equal to 4 factorial, which is equal to 24. Order is important. From a group of 4 students, looking at B now, from a group of 4 students, 3 are to be selected to serve on a committee. How many ways can they be selected? For B part, we're looking at the number of ways of selecting 3 students out of 4. Without regard for order now, we're just choosing any 3 students from the 4. So let's actually do it by identifying the 4 people as A, B, C, and D. How about that? How many ways can I choose 3 people of that 4? Well, I can choose A, B, C. That's one way. I can choose A, B, D. I can choose A, C, D. I can choose B, C, D. That's 4. And I think that's it. That's the only possible combinations of choosing 3 letters out of those 4. And again, the order doesn't matter in which I choose them. If I choose A, B, and C, or if I choose C, B, and A, I still get the same 3 people to serve on the committee. Order isn't important here. I still get the same 3 individuals. They're not being chosen for specific positions, so order is not important. I can choose A, B, and C to serve on a committee, or I can choose A, B, D, or I can choose A, C, D, or B, C, D. So the answer here is simply 4. There's 4 ways of doing this. Now the question is, how is the solution to this problem related to the solution to A? And the answer is this. If I were to take the total number of ways of choosing 3 people out of 4, which by the way is 24, this is the total number of ways of choosing 3 people out of 4. where order is important. You've got to realize that for each of those ways of choosing 3 people, there are 3 factorial ways of arranging those 3 people. So that's what we need to do here. We simply take this and divide it by 3 factorial. Because there's 3 factorial ways of arranging these 3. And the 3 factorial ways of arranging these 3 letters are included in this 24. This 24 here includes ABC, it includes ACB, it includes BAC, it includes CBA, and so on. So this solution includes all the different combinations of ABC, it includes all the different combinations of ABD, and so on and so on. So what we need to do is take the total number of ways of choosing 3 people out of 4 where order is important and divide by 3 factorial. Because 3 factorial ways of arranging each one of those combinations you see there. And the answer would become 24 divided by 6, which is equal to 4. That's the answer that I have there. So in actual fact, a combination of 4 choose 3, notice I'm using the symbol now C rather than P for a combination of 4 choose 3, is actually equal to the permutation of 4 choose 3 divided by 3 factorial. That's how the 2 are related. And I think it's important that you recognize the relationship here. The C of 4 choose 3 is equal to the P of 4 choose 3 divided by 3 factorial, which is that number right there, always. And again, it has to do with the fact that these 3 letters can be arranged in 3 factorial ways, which is 6 ways. These 3 letters can be arranged in 3 factorial ways. So all of these here include all of those other arrangements. We need to eliminate them, so we divide by 3 factorial. Okay, let's look at our formula for combinations. I gave you a bit of a hint towards it there a minute ago. But here it is. Given a set of n objects taken r at a time without regard to order. Again, the importance here is that without regard to order doesn't matter. The order in which you choose the r objects out of n doesn't matter. You still have the same r objects. Given a set of n objects taken r at a time without regard to order, the number of possible combinations is given by the formula. And there are 2 styles of notation used for combinations. It's the C of n choose r, which is equal to n factorial over n subtract r factorial times r factorial. Now, I normally write that r factorial on this side. It doesn't matter, of course, but I normally put it on that side. N factorial over n subtract r factorial times r factorial. That's why I've seen it most often. And another way of writing it is here. It's n choose r is equal to n factorial over n minus r factorial times r factorial. Same thing, but this is read as n choose r. But it means, it's important that you realize that that means the same as that. And I just want you to recall the formula for the P of n choose r. The P of n choose r is equal to n factorial over n minus r factorial. And remember I told you a minute ago that the C of n choose r is equal to the P of n choose r divided by r factorial. Now I can prove that to you because the P of n choose r is equal to n factorial over n subtract r factorial, now divided by r factorial. That would be n factorial over n subtract r factorial times 1 over r factorial, which is going to give me n factorial over n subtract r factorial times r factorial. So you see I do end up with my formula for the C of n choose r. And also important here, look, is that n has to be greater than or equal to 0 and r has to be greater than or equal to 0. N has to be greater than r. This number here is always greater than this one. Same as with your permutations. And both are greater than or equal to 0. Okay. Let's have a look at the first example here. There are 12 females and 18 males in a grade 12 class. The principal wishes to meet with a group of 5 students to discuss graduation. How many selections are possible? First thing you need to decide, is this a permutation or a combination? He's choosing 5 students out of the 30 that are in the class. The order in which he chooses those students, you need to ask yourself, does it matter? And the answer is no. Order doesn't matter. When he chooses these 5 students, he's going to have the same 5 students regardless of the order in which he chooses them. Doesn't matter if he calls out to, John before he calls out to April. Doesn't matter. The order doesn't matter here. So this is indeed a combination. So what we're simply doing here is we're choosing 5 students from the 30 students in the class. There are 12 females and 18 males, so there are 30 students in the class. He's choosing any 5. So the C of 30 choose 5 is going to be 30 factorial over 30 subtract 5 factorial times 5 factorial, which is equal to 30 factorial over 25 factorial times 5 factorial. And you do that on your calculator. And by the way, you should be able to do this on your calculator as well. And I'm sure that this has already been explained to you how to use your calculator. Most, not all students, but most students have a scientific calculator that has the C of N choose R on it. I, for example, got a TI-83. And on the TI-83 or the TI-84, you simply press 30, press the math key, go over to probability, and the C of N choose R, press that button, and you get choose 5, and you should get an answer here of 142506. And again, you should be able to find this on your calculator, the C of N choose R. Make sure that if that button is on your calculator, you can do this and you can get that answer that you see there. So again, on the TI-83 or TI-84, you press the 30 key, you type in 30, then you press math, okay? Then you go over to probability, and then you go down to number 3, which is NCR, and you press enter there. Just entering the steps here that you need to enter to do this correctly. And then you type the number 5, and then you press enter again. And when you do that, you will get the answer that you see there. So I just want to make sure everyone can do that on the TI-83 or the TI-84, okay? And again, some of you may have a different scientific calculator, but again, you should be able to find that button on your calculator and be able to use it correctly. In how many ways can 8 students line up at a fountain? Question, is it a permutation or a combination, first of all? That's the first thing to ask yourself. Does order matter? In how many ways can 8 students line up at a fountain? And here, order does matter. Because if we're looking at the number of arrangements of 8 students, if John is before April, that's different than if April is before John. Order does matter here. This is a permutation. And the quick and simple answer is simply 8 factorial ways of arranging the students. 8 factorial. Because again, if you think about permutations, you think about how many choices do I have for the first person in the line? I got 8. 8 choices. How many choices do I have for the next person in the line? I got 7, because I've already chosen my first person. How many choices do I have for the next person in the line? I got 6, and so on, right on down to 1. That, of course, is 8 factorial. 8 factorial, again, you should be able to do this pretty quickly on your calculator. 8, press the math key, go over to probability, and number 4 is factorial, and you get 40,320. So the answer in this case is D. Okay, let's have a look at another example. In how many ways can a debating club coach select a team from 6 grade 11 students and 7 grade 12 students if the team has to have 4 players? The team has to have 4 players. Again, is order important? That will help you determine whether this is a permutation or a combination. Is order important in terms of the order in which he chooses those 4 players? And the answer is no. This is a combination. Order is not important. He's choosing 4 members out of a total of, there are 6 grade 11 students and there are 7 grade 12 students. So he's choosing 4 students out of the 13 students in total. So again, do this on your calculator. The C of 13 choose 4, so 13 math, probability, C of N choose R, 4. 715 different ways of choosing those 4 members. Because he's choosing them from any 13 students. Doesn't matter what grade they're in, he's still only just choosing 4 students from the 13 students in total. Example 4. A store manager has selected 4 possible applicants, Albert, Bob, Cassandra, and Dominique, for 2 different positions at a department store. In how many ways can the manager fill this position? 2 different positions. And notice there are different positions. He needs to choose 2 people out of the 4 to fill these 2 specific positions, which are different positions. Is order important? If he chooses Albert for position 1 and Bob for position 2, is that different than choosing Bob for position 1 and Albert for position 2? And the answer is yes, that is different. So this is a permutation because order is important. So because it's a permutation, you are choosing from the 4 people you are choosing 2 with order being important. Again, you can do that on your calculator. P of 4, choose 2. 4, math key, go over to probability. Number 2, 4, choose 2 is 12. There are 12 ways of choosing 2 people from that group of 4. The other way to think about it is to think about it this way. Here's position 1. Here's position 2. How many choices does he have for the first position? He can choose any one of those 4 people. Once he chooses a person for position 1, how many choices does he have for position 2? The answer is 3. 4 times 3 is 12. He has 12 possible choices. Okay, let's look again at the key ideas here. To clue up, a permutation is an arrangement of objects in a definite order. The number of permutation of n objects taken r at a time is given by this formula. The p of n choose r equals n factorial where n subtract r factorial. A selection of objects in which order is not important is a combination. Order is not important. When determining the number of possibilities in a situation, if order matters, it's a permutation. If order does not matter, then it's a combination. The number of combinations of n objects taken r at a time can be expressed by the c of n choose r. Again, note that n is greater than or equal to r and r is greater than or equal to 0. A formula for the c of n choose r is, notice how that's written. I already explained that one to you. The c of n choose r equals p of n choose r over r factorial, or the c of n choose r equals n factorial over n subtract r factorial times r factorial. That's the one that you'll use most often. And that ends this lesson.